In this video, you'll be revising nomenclature. So our aims for this video are to define a number of different phrases. We've got empirical formula, molecular formula, structural formula, displayed formula, homologous series, and functional group, and also to be able to name any alkane, alkene, or haloalkane that, that an exam might throw at you. So there are four different formulae that you have to be able to define. So we've got empirical formula, molecular formula, structural formula, and displayed formula. And I've drawn four different formulae to try and explain each one of all of the same compound. So the first formula we're going to define is the molecular formula, and here is the molecular formula of the compound from the previous slide. And the molecular formula shows how many atoms of each element there are in the compound. So it shows you the basic information for the compound you've got. It shows you how many atoms of each element there are. So in this one, there are 4 carbon atoms, 8 hydrogen atoms, and 2 oxygen atoms. The next formula we're going to define is the empirical formula, which is this one here. So basically, what the empirical formula is a formula that shows the simplest whole number ratio in which the atoms of each element combine together. So the molecular form of the compound that we're looking at was C4H8O2. If you divide all those numbers by 2, then you get C2H4O. Now this formula does not represent what the compound actually looks like. It's simply the ratio in which the atoms combine together. So it's the simplest whole number ratio in which the atoms of each element combine together. And the important bit that people usually miss out of this definition is it's the atoms that combine together. You can't say the simplest whole number ratio in which the elements combine together. You have to say in which the atoms of each element combine together. Now, the next one we're going to define is the structural formula, which is this top formula up here in orange. And basically what the structural formula shows is the formula of the compound where the bonds aren't shown, but you can clearly see what is attached to each carbon atom. So the bonds aren't shown, but each carbon atom is written separately, so you haven't got C4 anymore, they're written separately. And the atoms or groups of atoms that attach to each carbon atom are clearly shown. So here this carbon atom has 3 H's attached to it, this carbon atom has 2 O's attached to it, this carbon atom has 2 H's attached to it, and this carbon atom has 3 H's attached to it, and these 4 carbons will all be in a line, in a carbon chain. You wouldn't have to define this one in an exam, but you would need to know what the examiner was expecting if it asked you to write or draw a structural formula. So a structural formula is where you can see the structure of the molecule, but you don't draw the bonds. If we now look at what a displayed formula is, and that's this purple one here, this is where you do show all the bonds. So a displayed formula is where all the atoms and all the bonds are shown in the molecule. And this leaves nothing to the imagination, if you like, in terms of where the atoms might be. It shows every single bond, and it shows every single atom in the molecule. Again, you wouldn't be expected to define this with words, but quite often an exam will ask you to draw a displayed formula. And if it asks you to draw a displayed formula, this is what it's expecting. So the last two things in this video that you've got to define are homologous series and functional group. So a homologous series is a set of organic compounds that have the same functional group but differ in chain length. So alkanes are a homologous series because they all have the same functional group, or a lack of a functional group if you like. It's just all single bonds, but you add a CH2 each time between methane, ethane, propane, butane, and so on. Alkenes are is a homologous series because you've got the same functional group, i.e. the double bond, and all that changes is the chain length, that you add a CH2 each time. But you may want to ask what a functional group is. And all a functional group is the atom or group of atoms that give the compound its chemical characteristics, if you like. So the alkene has a double bond, and it's the double bond that reacts in any reaction when you're reacting alkenes. So the functional group is the alkene or the OH group in an alcohol, and so on. It's the bit that gives the compound its name, but it's also the bit that gives it its chemical characteristics. So the most important thing that you need to learn from this video is how to name organic compounds. And here is an example. So you have to be able to name alkanes, alkenes, and haloalkanes. And this is a mixture of, well, it's not a mixture of them all, actually, it's not an alkane. But this is an alkene because it's got a double bond, and it's got halogen groups on it as well, chlorines here, as you can see. So the first step that you always have to take when you're naming an organic compound is finding the longest chain of carbon atoms. So you've got a chain here, which is a chain of 5 carbon atoms, and you've also actually got a chain here, which is also a chain of 5 carbon atoms. If you have a choice of 2, then always choose the chain that is in the longest line, if you like it, or sorry, in a straight line. So I'm going to choose this 5 in the middle. Now, depending on how long the longest chain is, you'll have different words to give to it. So if you've only got 1 carbon in the carbon chain, then it's meth. If it's 2 carbons, it's eth. 3 carbons, it's prop. 4 carbons, it's bute. 5 carbons, it's pent. And 6 carbons, it is hex. So 1 carbon is meth. 2 carbons is eth. 3 carbons is prop. 4 carbons is bute, 5 carbons is pent, and 6 carbons is hex. You will never be expected in this exam to go further than 6 carbons. So if we count the number of carbons in the longest chain, we will find that there are 5 carbons in that longest chain of carbons. Okay, so I circle them there just so you can see them, so it'll be pent as our first part of the word, of the name, if you like. Now, once you've got the first part of the name sorted, I would cross out the bits that name, that bit of the name represents, because you don't want to count those bits twice. So it's naming this carbon, this carbon, this carbon, this carbon, this carbon. Those are the 5 in the longest chain. The next thing you've got to do is work out whether it's an alkane or an alkene. And you can see there's a double bond here, so therefore this is an alkene. Now, if it's an alkene, then it's going to be pentene. If it's an alkane, it would be pentane. Not only do you have to say that it's pentene, but you also have to say where that double bond starts. Now, the double bond is the thing that you name first in terms of numbering. And what you do is you make sure the double bond has the lowest number. When I say that, I mean that you count, you give numbers to each carbon atom in the chain. And you can see in this case that the double bond starts on the second carbon. It's the one that it starts on. So this would be called pent-2-ene, and so I've named that double bond as well, so now I can cross it out. I would then circle the things you haven't named yet, and that is these 2 chlorines and this CH3 here, because that CH3 wasn't part of the longest chain, so that hasn't been named yet. Now, there are a number of different words we have to give to different bits that come off the carbon chain. So for halogen groups, if it's an F, then it's fluoro, Br is bromo, I is iodo, and Cl is chloro, so I didn't put those in order. And then if you've got a CH3 group, that's called a methyl group. The ones you name first are the ones that come first alphabetically. So out of chloro, which are these Cl groups, and methyl, this group here, chloro is going to come first because C is before M in the alphabet. So this is going to be, we've got two chloro groups, so therefore we'll name them both at the same time. If you've got two groups, then we say dichloro. If you've got three groups, we say trichloro. And if you've got four groups, we say tetrachloro. Now, we can't just say dichloro. We've always got to say where those chlorines are. And so we use these numbered atoms, these numbered carbons again. One of the chlorines is on the second carbon, and one of the chlorines is on the third carbon. So we call this 2,3-dichloro, and then we put the methyl group, 4-methyl-pentuene. 2,3-dichloro, 4-methyl-pentuene. Normally that would all be on one line, but I just couldn't fit it in this case. Notice that there are commas between numbers and there are dashes between numbers and letters, and that's always the case. Now I'm just going to do another example because there are a couple of ways that an exam will try and trick you, not intentionally I'm sure, but they will make them slightly more difficult by either making the chain go in lots of directions and also to put some bonds in and some not bonds. Okay, so you've got CH3s here, these are also CH3s here. So, but the process is exactly the same. The first thing we do is find the longest carbon chain. So we've got 1, 2, 3, 4, 5, 6, or we've got 1, 2, 3, 4, 5, 6. It doesn't matter which one we choose, so I'm going to choose this one here. And the first mistake some people make is to not count these CH3s in the longest chain. But they are in the longest chain, they are carbon, so I'm going to count that one there. So that is 6 carbons in the longest chain, therefore it's going to be a hex. And there are no double bonds, therefore it's an alkane, so therefore it's hexane. Now we've got to put the bits on the front of this name to take into account the bits that we haven't named. So that's this methyl group here and these two bromo groups here. Because bromo comes alphabetically before methyl, we're going to name the bromo groups first, but we're not going to number the carbons from this carbon this time, because that would give a bigger number than if we numbered the carbons from this end. Remember, if we could just turn this molecule, or flip this molecule over, it'd be exactly the same, we'd just be looking at it from a different direction, if you like. So we can number the carbons from this end, and that will give us lower numbers for our labels for these groups that are coming off it. So I'm going to go 1, 2, 3, 4, 5, 6. Because we do these alphabetically, we're going to name the bromo groups first. So this is going to be 3,3-dibromo, and you've got to make sure that you say where both the bromo groups are. It is very easy for people to get this wrong and just put 3-dibromo. But you're only saying where one of the bromo groups is then. You've got to say where both of them are. So 3,3-dibromo, and then the methyl groups on the second carbon. So 2-methyl hexane. And that's what you'd call this compound here.